In today's lesson, we are going to dive deep into vectors. Let's try to distinguish between vector quantities and scalar quantities. You might already know the difference between vector quantities and scalar quantities. The vectors are the physical quantities which are having a magnitude and a direction in the meantime. Scalar quantities only have a magnitude. The magnitude defines how big the physical quantity is. Now, let me ask you a question. If I walk to the right direction, just 5 meters, and if I walk to the left direction, another 5 meters, how much would I spend on these two journeys? The magnitude doesn't matter, my problem is sign. Could it ever be negative when I walk to the left? Could it ever be negative 25 joules? Or when you walk to the right, could it ever be positive 25 joules? The simplest answer is no. So this clearly shows that this energy does not depend on the direction where you move. Simply, energy is not a factor which depends on the direction. But let me tell you something else. Now imagine if I say that 2 5 Newton forces are exerted upon an object and you are supposed to find the resultant on this object. Would you ever be able to find the resultant on this object? Think. The simplest answer is no. Unless you know the direction of these two forces, you will never be able to find the final resultant or the direction of the resultant. Let's try to properly learn these concepts today. Let's dive deep into this lesson. Let me explain this part to make it clearer. So vectors, you already know what the vectors are. As I have already explained what the vectors are, the physical quantities which have a direction and a magnitude, and scalars are the physical quantities which only have a magnitude. And to make it more clear, I'm going to introduce some of the vector physical quantities and some of the scalar quantities. Right, the very first vector quantity is displacement that I'm going to introduce. Displacement. Sometimes you might already know what the displacement is. If you don't know the displacement and the corresponding scalar is a distance, if you don't know really the difference between displacement and the distance, don't worry, I'm going to explain it later. In kinematics, we will meet this lesson again, and I'm going to introduce the difference between displacement and distance. And the second vector quantity is velocity, and the velocity's brother is a speed, which is there on the other side, which represents the scalar part of the velocity. And the next important vector quantity is acceleration, and there's no corresponding scalar term on the scalar side, so I write something else like work and energy. The work and energy terms are almost same, but they sound different a bit, so I'm going to explain later the major difference between these two terms, so energy and work. And on the vector side, I write force is a vector, and even momentum is a vector, and electric current is a vector as the current has a direction. Electric current, and you will meet later on um, electric field or simply field theory, every field has a direction, so we should never forget to write field. And on the on the scalar side, we can write one more scalar, which is a temperature, which doesn't have a direction. And I can write few more, mass, time, and there are plenty of scalar quantities you can write. But I pause here and let you think and write more if you want. And the next key lesson is representation of vectors. This is a very vital, this plays a vital role. It's a very important key lesson because we already know a vector has two important identities, the direction and a magnitude. So if you are unable to represent any of those things, simply you're not capable of representing both of these information. And so you have to make sure you represent both of these important information when you represent a vector. So the simplest possible way in A level we have, but in university level, in master's level, we use some really complicated other methods like matrices and some other methods to represent vectors. But here we have not hard as much as that. The concepts are quite easy here. The easiest possible way that we can use is an arrow to represent a vector. This arrow, the length of the arrow simply represents the magnitude of the vector. The magnitude is represented by the length of the arrow. Longer the arrow, higher the magnitude. And the direction is, it's crystal clear, the arrowhead. So this arrowhead represents the direction of the vector. The direction and length is represented by the magnitude is represented by the length. For example, imagine if you have a vector of magnitude 10 newtons pointing in a direction like this, and if you want to draw, now imagine the length of this single line. This line is let me take 4 centimeters, and if you want to ever represent another vector which is pointing to same direction but half of the magnitude, in the sense 5 newtons, this is what you're supposed to do. You have to make sure the length of the line is half of the previous length. So now the length of this line should definitely be 2 centimeters, and it properly follows the expected scale. So here in Edexcel IAL levels, scale drawings play a vital role because most of the time we draw scale diagrams to find sometimes a resultant of a vector system or to indicate vectors. So you need to, I encourage you and I urge you to keep a ruler with you and a protractor with you throughout the entire session. Right, and there's an activity now. So there's an example question I want you to give a try. Right, just right, you can pause the video and try to do this example, and then you can follow what I'm going to do now. Right, the question says a wind is flowing from south to north with a speed of 24 meters per second. Right, now there's a wind flow, and right now, as there's no other way to represent these directions, what I'm going to do is I'm going to indicate all the expected directions like this. So this is my north, and this arrow is representing a south direction, and this is the east, and this is west. Right, now a vehicle is moving from east to west at 12 meters per second. Show the velocity of the wind and the velocity of the vehicle using a proper vector representation. Right, now my first concern is the direction. Now look at the wind, which is pointing in north. So you can draw your own diagram, 24 meters per second, and imagine if you take the scale properly, and if the length of this vector is just 10 centimeters or something, you can choose a relevant scale as you wish. But here I recommend you to take simply 6 centimeters to represent 24 meters per second. And now the speed of the vehicle is half of the speed of the wind. So speed of the vehicle is 12 meters per second. 12 meters per second, and the length of this is supposed to be 6 over 2, which is 3 centimeters. 3 centimeters to represent 12 meters per second. Right, now it has already satisfied the direction requirement as well, because this is pointing from, oh my bad, it's pointing from, no, it's traveling from east to west, so I want to oppose the direction of the arrow head. Right, so this will be the vector. That's totally fine. Okay, now let's go to the next part of this lesson. The next question. Right. Example number 2 is, two forces are acted upon an object as shown in the figure. Draw a proper scale diagram to indicate both of these forces. Now you should pick a relevant scale here. Now 28 and 49. So I should pick 1 centimeters to represent 7 newtons. So but in order to represent 28 newtons, I should draw a line of length 4 centimeters, because 7 times 4 is equal to 28. So now this length is equivalent to the magnitude of the vector 28 newtons. And similarly, I can length of the line, the appropriate length of the line to represent this 49 newtons is 7 centimeters, right? As I haven't specifically indicated the angle between these two vectors. You don't really want to indicate an angle, so just leave it. Right, so simple as that. This is what I really want you to do. Let's try to theoretically determine the resultant of a vector system. Unless the vectors are parallel to each other, we have to use the method that I'm going to introduce to you now to find the resultant of a vector system. Right, now if the two vectors are parallel to each other, it's less complicated anyway, as you can directly find. You can just add them together or subtract to find the ultimate resultant. For example, imagine if one is pointing to left, right, 100 newtons, and the other force is pointing to left with 20 newtons. We can directly find the resultant if you want, which is 100 minus 20 is 80 newtons, pointing to right. It's anywhere less complicated, very simple. But now imagine if you ever end up getting a vector system like this, how would you find the resultant of these two vectors? Right, now this is what I'm going to explain now. Very first step is the scale. So if you don't choose the right scale, you will be in deep trouble. As here, what we are going to do is we are going to draw a proper appropriate scale diagram to find the resultant. So I encourage you to choose a relevant scale which really helps you to continue your working. So this time I think I can choose 4 centimeters to represent 1 Newton. So in order to represent 12 Newtons, a line of length of 3 centimeters will be required, and to represent 8 Newtons, a line of length 2 centimeters will be required. So you can use your ruler to draw these two lines, right? And the next important thing is any vector has two important points. If this is your vector, right, so imagine now this is a vector. If this is your a vector, these 2 points are important. This is called the head of the vector. Head of the vector. While this is the tail of the vector. Head of the vector and the tail of the vector. Right. Now, from the resultant point of view, if you want to find the resultant, make sure you connect head of the vector to the tail of the next vector. So now, as there are two vectors here, you have to make sure you connect head of the first vector to tail of the second vector to find the resultant. Now, can you see that already, or in the original diagram, head of the first vector is connected with the tail of the head of the first vector is connected with head of the next vector, second vector, 12 Newtons. So this is not an appropriate arrangement to find the resultant. So I have to dislocate one of the vector now, right? So I have to dislocate or unplug one of the vector and connect it with the head or tail properly. We have to satisfy head tail combination here. So now what I'm going to do is 8 Newtons I don't keep. So 8 I keep it as it is. I'm not going to move these 8 Newtons, and this is where my first vector. I'm not going to change the orientation of the second or the vector which is already been removed from this, and this is where it was pointing previously. So, and the angle between these two vectors is it was 40 degrees, and now I'm going to replace the same. I'm not going to even change the orientation or the direction where it is acting like this. I just keep it as it is, but I have just satisfied the condition required to find the resultant. The head to tail requirement has just been satisfied, and the length of this vector, and it's 12 Newtons, and we already know the lengths of each side. So 8 Newtons is simply 2 centimeters is required to represent this length, and here 3 centimeters as we already cleared. And now the resultant is and the next important thing is, if you use the protractor to find the angles, make sure you get the right angle between these two. Now this angle is geometrically, you can figure out how much would this angle be. It is definitely 140 degrees. You can measure this angle using your protractor. So now the open tail. So this one's tail is open. This is the open tail. and the open head, and this is the head of the vector, which is open end of the head. Now I'm going to connect the open tail and open head to find the resultant, and the direction of the resultant is always pointing from tail to head, right? So now I can find, yeah, you already know the scale, so just measure the length of this line and multiply it by the relevant scale, which will eventually lead you to find the resultant. And the direction matters. We already know a result or vector is not a vector if you doesn't represent the direction properly. So if you don't represent the direction properly, so make sure you properly measure this angle using your protractor. So measure this angle. So if it is alpha, you can still find out this alpha angle between 8 newtons and this resultant. So this is the method you have to follow to find the resultant. Okay, I have already provided all the steps. The steps, step number 1 to step number 4 will simply direct you to find the resultant if you are looking for the resultant, right? So that's all about the resultant, right? And the next key lesson is a resultant of two perpendicular vectors. If vectors are perpendicular to each other, then this is very important, because most of the time we deal with perpendicular vectors in Edexcel A levels. So we should be able to work with these vector systems really well, right? Now imagine, theoretically we already know, now there's a little problem with this vector system, as we already come to know here, there's a little problem with this. Can you see the head of the A vector is connected with head of the B vector, not an appropriate orientation to find the resultant. So I have to dislocate this from this end and rearrange the vector arrangement or vector system in favor of finding the resultant this time. So I'm going to keep the A vector as it is here, not going to even change the direction or position or the arrangement of the A vector, but I'm going to change the position of B vector like this. Still they are perpendicular to each other, right? So now my vector arrangement is ready to provide the resultant force or vector, not the force actually, the vector, right? Now open end and open tail, let's connect them together again, right? So now I've just connected open tail and open head, which leads us to find the resultant. Right now, this time we can use one of the key relationship directly to find the resultant if you want. You already know that key relationship, which is Pythagoras theorem, right? So we can make use of Pythagoras theorem to find the resultant. Right, so you can get finally with the help of Pythagoras theorem, you will be able to find out r is equal to a squared plus b squared square root, and even the angle r is equal to, sorry my bad, if you want to find the angle, because we already know that in order for us to represent the direction properly, this angle matters the most. So I can use tan alpha. The tan relationship is opposite side, as this is a triangular shape, not just a triangle, it's a right angle triangle. So I can still find the tan alpha opposite side B over hypotenuse or adjacent side A. So alpha is equal to tan inverse B over A. Let me do these two examples for you. A swimmer swims perpendicular to the banks of a river at a velocity of 4 meters per second. The direction has not specifically been mentioned, it doesn't matter. So if this is the river, there's a a river stream down the river, and the speed of the stream is 4 meters per second, right? The downstream is 4 meters per second at oh my bad, so the river stream is 3 meters per second. It's 3 meters per second, and there's a person waiting over here to cross the river, and he's going to swim now at a speed of 4 meters per second, and we are expected to find the resultant of the swimmer, right? Now, as we already learned previously, you can draw a proper vector diagram to find out the resultant, right? So the 4 meters per second is the vertical component of this, and while the horizontal component is 3 meters per second. This should definitely be longer than this line, as this is more, as this is greater. This is 3 meters per second, which is less than 4 meters per second, right? Now I have already satisfied the required condition, which is connecting head with the tail, right? Now open two ends, open head and open tail can be connected like this to find the resultant, as that is our ultimate objective. At the end of the day, we are supposed to find the resultant. So R is now equal to 4 squared plus 3 squared square root. It's a very popular Pythagoras numbers, so you can end up getting 5 meters per second. So this is the resultant velocity of the person, and even the direction can also be found with respect to this the direction, or the with respect to the banks, or with respect to the vertical direction. You can find the resultant. So this time I'm going to find the resultant with respect to the vertical. So tan alpha is equal to 3/4. So finally I can find the angle is tan inverse 3/4, right? You can use this method anytime you want to find the resultant, right? Let me do the question number 2. Two unknown forces with equal magnitudes act on an object perpendicularly to each other. If the magnitude of the resultant is 8 newtons, find the magnitude of each force, right? It is relatively a simple question. We don't know the magnitude of these two forces. Let me take the magnitude of a force is F, and the resultant is already known, which is 8 newtons, right? Again, we can apply these things to Pythagoras theorem. F squared plus F squared is equal to 8 squared, right? So then 2F squared is equal to 8 squared. Let's simplify this furthermore. F is equal to 64/2 and the square root of it. You can calculate and find the final answer, right? I leave it for you to find the resultant final value, right? Example number 3. Let me do the example number 3 for you. But to erase this space, as we need more space to do this part, I just erase this part and get some space, right? The velocity, no, not just velocity, vertical velocity component of a ball is 4 meters per second. If the magnitude of the velocity of the ball is 12 meters per second, find the horizontal component of the ball and angle between the direction of the velocity of the ball, the vertical velocity of the component, right? So this time we are expected to find Yeah, vertical velocity component. Okay, we already know vertical velocity component and the horizontal velocity component combinedly create the resultant. So if this is the vertical velocity component which is unknown, and I just put x to the magnitude, as I don't know the length of the vector or the magnitude of the vector. So I take x as the length or the magnitude, not the length, magnitude of the vector. And the horizontal velocity is 12 meters per second, which is already been provided, as we already know that. Find the horizontal component of the ball on, oh, my bad. I made a slight mistake. So what we don't know is this component. So which is magnitude of the velocity of the ball is given, which is 12. This is the resultant. Vertical velocity component is 4 meters per second. That's already been provided, and this is what the unknown term is. So let me take it as x, as this is the unknown term we are expected to find. Again, our friend is Pythagoras theorem. Let's try to apply Pythagoras theorem to find what the resultant is. X squared plus 4 squared is equal to 12 squared. X squared plus 4 squared is equal to 12 squared. Right. And bring the 4 squared term onto other side. You end up getting 12 squared minus 4 squared. So x is equal to 12 squared minus 4 squared square root of it. Right. Now use your calculator to find the final answer. Right. So that's all. Right. This is how we use these right angle triangles to find the resultants or some vector based concepts. You can see the bag in my hand. Right, now I'm going to exert another horizontal force on this. Right, let's try to recognize all the forces on this. Now you can see very first force is weight of the bag, and the second important force is the horizontal forces exerted by my finger, and third force is the force in the string. Right, now this force, the force exerted by my finger, is a horizontal force and weight is a vertical force. In the sense, if you want to counteract both of these forces in order for you to keep this in equilibrium, this force, the force in the string, should have two components which are opposing this horizontal force, which is acting to the right side, and the weight which is downwards. Let's dive deep into this. I'm going to explain what the vector resolution is. Let me introduce you what the vector resolution is. The vector resolution is the heart of mechanics, because any vector, so in this concept we learn that any vector can be resolved in two perpendicular directions. Let me walk through this concept carefully, and I really want to plant this concept properly in your mind. So hang on, I'm going to help you with this. Now let me consider this case. Now imagine I'm going to place, and this is a grid, and this is the y-axis. Let me consider this as the vertical axis, and this is the x-axis, and we can treat it as the horizontal axis. And I'm going to place this object somewhere here, and this is an object. When this object, imagine a moment that this object is traveling in x direction. Right. So the total displacement obtained by the object is now completely horizontal when it travels in this x direction. So if this object travels 10 meters, you can say distance traveled in x direction. So in this case, the distance traveled in x direction is 10 meters. It's super cool. And I place another object. Now this time this is the orange color object, and at the same position, at the same time, another white color object is also going to start its motion, and it is subjected to move in this direction, in the sense y direction. Imagine, right? So the final displacement of this object is completely vertical. It's completely vertical. So if you just measure, so let me take that this object has traveled 10 meters in this direction. So the distance travel in x direction, this time y direction, I mean my orange color object here traveled. So this is the orange color object. It has traveled 10 meters already in x direction, and now distance traveled by my white color object, white object in y direction is 10 meters. And here it's crystal clear. Now the distance traveled in y direction, I mean the same object, this orange color object, the distance traveled in y direction is 0. But here the distance traveled by, same as that, distance traveled by x direction, in the sense the white object is also 0 meters. But now I pick another random color, this time this pale blue color object. So this is the breakthrough, or this is the fascinating or interesting concept here. Imagine the same distance traveled, but this time in a different path. The 10 meters traveled by another blue color object, but in a tilted path like this. So this is come inclined and tilted to the path where this is moving, right? So now, my new object, this object, right, finally shows up somewhere here. Imagine if you're supposed to find the displacement. Now you can clearly see that the same object's displacement, you can find it in x direction as well as y direction, right? So this has an impact on x direction as well as the y direction. So this is very, very important. This is what we consider as the vector resolution. Now this vector can make an impact in two perpendicular directions like this. So in physics, we recognize this as the vector resolution. So you can measure this as, I don't know the exact distance this time because I don't know the angle. So I'm not going to exactly identify this length, as magnitude doesn't matter this time because that's not my major concern, as I'm trying to introduce the concept here. So I can identify that this one has traveled, this one has obtained y, so my bad, x displacement. So here x, 1 or something in x-axis and in y-axis. So you can just take it as y1 or something like that. So now just keep this concept strongly in your mind, as I'm going to make it more clear. I'm going to discuss now, I'm going to apply this concept, and I'm going to simply use trigonometry to teach the same concept deeply and intuitively, right? Let's try to figure out this concept properly. Imagine if you have a right angle triangle. Now imagine, so completely forget what we have just discussed, and instead of that, now there's a triangle here. You have got a triangle, and this is the hypotenuse of the triangle, and the length of the hypotenuse of the triangle is P. Imagine you are expected to find the length of these two sides, opposite side of the triangle, uh, with respect to the alpha angle. You are supposed to find the opposite side of the triangle and the adjacent side of this triangle. Now you already know the sine, cos, and tan simple trigonometric relationships are not really new to you. I'm pretty sure you already know what these concepts are. So now I can say that the sine alpha is equal to opposite side. Let me label these things. So this is my A, B, and C. So sine alpha is equal to AB is opposite side over BC, right? Oh, sorry. Sine alpha is, I made a slight mistake. It's totally fine. I'm even not going to pause this video because I know you can manage this. So opposite side over AB over hypotenuse, which is AC, right? So if I put the values, now I know already the length of the hypotenuse, which is P. What I don't know is AB, so I'm expecting to find AB here. So I bring the P onto other side, so I end up getting P sine alpha is equal to AB. Nice. So I'm directly going to write this in front of this. Then phi sine alpha is equal to AB. Furthermore, I need to find the length of BC in terms of P and alpha. So in my next attempt, I'm going to find the length of the BC in terms of P and alpha. So I'm going to use cos alpha relationship. Cos alpha is equal to the or adjacent side, which is BC, over AC. Let me put the values. BC over AC is P. You can bring this P onto other side, so you end up getting P cos alpha is equal to BC. So I rewrite this value here, P cos alpha. Right. You can take a note if you want. I urge you to take down this note, as it is very important for you to understand these concepts. Right. Now, last not least, I have just recognized a very powerful relationship. Now, if I have a triangle now, instead of a triangle now, this time I'm going to deal with a vector, right? So this is my vector. Imagine I'm going to find the components, two perpendicular components, right? And the angle between one of the sides. Let me take this is P. The magnitude of the vector is P, and angle between the vector and the horizontal direction or horizontal is alpha. Same as our previous case, I'm going to complete this triangle now. Even though it is a vector, you are totally free to use geometry, right? So you are not being avoided. So you can use trigonometry to find some relationships. Now I can see, now this is my horizontal component, or you can say horizontal component, but it's not always horizontal. It is not always supposed to be horizontal. Sometimes it can be something else, but here just for simplicity, just to make it clear, I treat this as the horizontal component, and this is my vertical component. Right. So, but we have just learned that if you treat this as a right angle triangle. This is the P cos alpha side, and this is the P sin alpha, which is opposite side, P sin alpha. So it's clear that these two sides are equal in length, as this is now this is a rectangle, so this is when this is P sin alpha, so this side is also P sin alpha, right? So I have just derived something very important, guys. If you can clearly see that when this one is P, these two sides are, so this side and this side, this is P cos alpha in terms of this angle, and this vector, this is P cos alpha, and this is P sin alpha, which is very important. So we can use this relationship to resolve vectors, no matter what the vector is. Right, let me do this question for you. I know this is relatively a simple question, so you will encounter some complicated questions later. Right, but let's try to find out the two perpendicular components with respect to the given vector and the angle. So you have to recognize what the adjacent side is and the opposite side. So when you recognize these two important sides, if you can recognize these two sides, you can directly apply what we have just learned. So now this is the with respect to, in terms of the given information, you can recognize this is the adjacent side, while this is the opposite side of the triangle. This time, if you can't clearly see whether this is the opposite side, just draw this side, and you can now clearly see that these two sides are simply equal in length, and these two sides are also equal in length. Simple. So now this is 95 cos 50. The value doesn't matter, actually. It's not my major concern. But my ultimate objective is teaching how to get these components in terms of the vector and the angle. So now this is 95 cos 50 and this is 95 sin 50. Right. That is it. Right. A little complicated one compared to previous one. It's somewhat complicated, but not as much as next questions. I mean, this question and the other question. And yeah, you can try this out if you want. Pause the video and first of all, try to do all of those questions, and then you can then play the video again and watch what I'm doing with these vector questions. You're totally free to do that. Right. So now this question. Again, this time the corresponding adjacent side is this one. So this is my adjacent side, AS, and this is my OS, opposite side, right, with respect to given information here. So this is now 50 cos 70 and this is 50 sin 70. Just make use of your calculator to find the values of them, but that is not my major concern, as I mentioned previously. And also here, with this is 4.5 meters per second, and here now you have to recognize these two major sides, and these are the two perpendicular components, which is 4.5 cos 50 and this is 4.5 sin 50, because it's crystal clear that this is the adjacent side of this and this is the opposite side of that, right? Okay, now this is the next given vector system. This is 100 and this is 100 cos 25 and this is 100 sin 25, as this is 25. 25. As this is the adjacent side and this is the opposite side this time, I'm not going to complete the triangle as it's crystal clear and it's obvious. You can clearly see the adjacent side and the opposite side in this diagram, so there's no point of drawing the diagram again. Right, now this is not a very common question and it's somewhat complicated as this is a bit extraordinary question compared to what we have done so far. Don't worry, I'm going to help you out. Okay, now you need to clearly see that this side, if you, right, so now this is a plane. I want you to find these two sides in terms of this angle 28 and the given vector which is 35 newtons. I want you to find these two sides. This is the adjacent and this is the, so we don't know whether this is adjacent or this is opposite with respect to the given values or not. So we should try to identify and let's try to figure out. Now this is 90 degrees and you can also consider, if you want, that right, you can draw a line parallel to this line. Now these lines are parallel to each other and these two lines are parallel to each other. So when this is 28 degrees, this angle is also 28 degrees. When that is 28 degrees, you can see that this is 90 degrees in the sense this is 90 minus 28. So this value is going to be now 90 minus 28, which is 62 degrees. 62 degrees. Right. So now in terms of this 62 degrees and this angle, you can identify these two perpendicular vectors and the value of these two perpendicular vectors. Right. So let's try to identify the values. Right. Now here 35 and this is 35 cos 62 and this is 35 sine 62 degrees. You can find the values if you want. And also you can clearly see that this angle is, and here to there, this is also 90 degrees. If you carefully observe, you can identify that this angle is 28 degrees. I draw it very carefully. So here you can identify something very important here. When you place something on a plane like this, no matter what the object is, imagine there's a plane and this angle is alpha. So angle to the horizontal is alpha, and you place a particular object on the plane. And if you expect to find, now imagine if this is the weight of this, and if you are expected to find these two components, always remember this angle is, right, conventionally you can find what that angle is. It's also alpha. So in terms of W and alpha, you can find out this is W sine alpha and this is W, sorry, my bad, cos alpha here, as is the adjacent side is crystal clear, W cos alpha, while this is the W sine alpha. Right, that is it. Very important. Let's walk through some exam oriented questions. Right, so let's read this question carefully. I'll encourage you to read this question and pause my video and try to answer this question. Yeah, the document is already been attached to the website. You can download the document if you want and try to do some of these questions. All of these questions I encourage you to do, and I'm going to discuss some of the questions with you now. Right, now the first question, And this is exactly the exam order. Edexcel A-level MCQs usually follow this standard order. You'll be able to find the answer to the question with a cross in the box, yeah, if you think that it's correct. Right, okay. So I'm not going to read that part, as you already know what the exam order is. So the question is, a student walked 12 kilometers on bearing of 135 degrees, and then walked 20 kilometers on a bearing of 340 as shown. Right, the question is, which of the following could represent the final displacement of the student's starting point? Right, now this is actually the diagrams are given to the scale, and you are expected to draw a proper scale drawing to identify these guys. Otherwise, there's no other way to recognize what the final vector is. So when you draw a proper scale drawing, now take a look at this. Length of this one is 20 kilometers, and this one is 20 kilometers, and this is 12 kilometers. So you can without even measuring, you can simply draw another line. Now draw a line representing the north direction, because all the lines are drawn with respective to north direction. So just indicate how the north appears, and then here angle between this, the north side, and this one, because when it comes to bearing, guys, we always measure the clockwise angle. So that's why they have provided this angle. It doesn't mean that you can't ever use this. You can even use this angle if you want. So this is 20 degrees, right? The angle of this angle is 20 degrees. So now, yeah, so you can draw this line, right? You can draw this line, and with the same length, right, without even changing that, you can draw the line, and you will end up getting this answer, because now this angle is 20 degrees. This is very important. Use protractor properly. Use a protractor to measure this angle, and even the length of this one should properly be measured, and then draw the line accordingly. So now you already know the, yeah, this is my first vector and this is my second vector, and two open ends are, and this is the open tail and this is the open head. You can connect these things together, you end up getting this answer, right? So the answer will be answer B. You have to measure properly and identify the length of this line. Then only you can recognize what the exact answer is, right? So that is it. Then go to the part 2. Second question is, the steps on an escalator moves with a speed. This is relatively a simple question, guys. The steps on an escalator move with a speed of 0.5 meters per second. Just imagine the incident, right? I usually encourage kids to imagine these sort of concepts and these sort of incidents, so then only you can properly identify the answer. To approach the answer properly, they need to imagine this stuff. So the vertical component of the velocity is 0.3 meters per second upwards, right? 0.3. Okay, now this has already been given, and they expect you to find this component, right? So now when you resolve this component, either you can resolve, or you can just identify that these two combinedly produce the resultant. Because imagine if you are the one who's standing on this escalator, this is what you feel. The velocity what you feel now is this 0.5 meters per second, right? So this is the combined outcome of this velocity. So now you should be smart enough to figure out that when this is 0.3 meters per second, and this should be what you are supposed to find. So let me take that is V. I don't know how much this velocity is. So I'm going to find it out now, right? So these two vertical components combinedly produce the resultant effect what you are experiencing right now, which is 0.5 meters per second. So here it is 0.5 meters per second, right? Now let me find. Now v squared is equal to v squared plus 0.3 squared is equal to 0.5 squared. We can use Pythagoras theorem to work this out. And 0.5 squared minus 0.3 squared, the total square root of this will give you the final answer, which is 0.4 meters per second is the final answer, right? So you can pick the correct answer, which is second answer, right? Question number 3 is, which of the following is a vector quantity? Very simple. As we have already recognized most of the vector components and most of the vector quantities, we can usually identify what the vector quantities are. So out of these vector quantities, these physical quantities, I think work done, yep, I have already told you that work is a scalar quantity, time is also a scalar, even temperature is a scalar. So displacement is the only vector quantity you can find out of these 4. Right, then question number 4. This is a very interesting question, very interesting one. The diagram below shows the velocity of an object before and after a force is applied. Before and after a force is applied, right? The magnitude of the velocity did not change. Yeah, magnitude of velocity hasn't changed. So which of the following arrows represent the direction of the change in velocity? Change in velocity, right? So this change in velocity is responsible to change the previous velocity into the new state of the velocity. So now which one should be responsible to do this? Right, I have come across another very interesting question, guys. So through this question you will be able to see how we can view various type of questions from the vector perspective, and this is a very pure vector question. So I'm going to solve it for you. Now take a look at this. Let's quickly walk through this carefully. The diagram below shows the velocity of an object before and after a force is applied. The magnitude of the velocity did not change, right? So then as in magnitude of the velocity before is v, and same as that velocity after must also be v. Right, now if you use your inner intuition, you can that's the very first method actually, guys. You can use 2 different methods, 2 different approaches to get the final answer. I'm going to teach you both of these methods, as both of these methods will help you in 2 different ways, and yeah, by mastering both of these methods you can improve your inner intuition. When it comes to another question, you'll be able to confidently answer these sort of questions, right? So I'm going to use the very first method, which is quite easy, right? So now you can clearly see that a change is required. Now this is my previous vector before. A change must be applied on this, whatever the change is, should eventually give us, the after this vector, right? This is what we need to get. So now if this is v, right, now you can use common sense to recognize that a vector like this is required to get. Now imagine when you add these 2 vectors together, right? I have connected head to tail of these vectors, so I would end up with this vector, and this is going to be my resultant. So now, yeah, so this is our change. Simply, this is a change in velocity right, which eventually brings the requirement we want, and this is our v. So but this is not a very mathematical or methodical approach, so I'm going to use another mathematical methodical approach, a kind of a methodical approach, to get the final answer. Imagine if you ever come across a bit complicated one than this, right? In unit 4 we have more complicated questions. So if you ever come across a question like that, so you have to use in-depth method, kind of a intuitive or a kind of a methodical method, so like this, that I'm going to teach you now. So now, yeah, what is a change? This is very important. Change in velocity. Let's try to figure out change in velocity, what the change in velocity is. Always, guys, change in something. For example, the change in mass, yeah, your mass in last 10 years, if I ever ask you to identify the change in mass, right, you will quickly go through your previous records and you will find your previous mass, right? 10 years ago, your previous mass, you would definitely find out what your previous mass was 10 years ago. And then if you have a scale at your home, you will definitely measure your new current mass, and you will get the change in mass. How? Previous mass, sorry, the final mass minus previous mass, right, gives you the change in mass. Then similarly here, change in velocity is the final velocity minus initial velocity. Final velocity minus initial velocity. Right, now the final velocity is, yeah, we don't exactly know the direction, but we know this velocity is something like this. Minus initially it was upwards, so we can draw it like this, right? So now the lengths are equal, right? Now the turning point of this lesson, oh, this is the pivotal point we come across, and as this is very important, always remember, guys, you can I recommend you to watch this 2 or 3 times if you don't understand, as this is that important. So now, yeah, if this is the v and negative vectors, if you ever come across a negative vector like this, just change its direction, because negative vectors doesn't make any sense, guys, as you can't directly deal with, or you can directly work with a negative vector. You can't directly connect this negative vector to a vector system. So you have to use a different approach, which is more technical. So then here what we do is we simply oppose this to our direction like this. It makes sense because another vector addition here, right? So now when you add these two vectors, right, we'll end up with something like this. Now v and this vector looks like this. So anyway, the length of this vector is v, and my bad. So from the length point of view, so this is the first vector v, and this is the second vector v, right? So now yeah, this is v and this is v, right? So this will allow us to get the final resultant vector. So now connect the starting point and the ending point of the vector, which directly allows you to find the resultant vector, which is this, right? So now, yeah, now this is the confirmation. This result will confirm this must be your final answer, which is delta v here, not v, my bad, it's delta v. That's a change in velocity. So we can go with this answer. Let's wrap up the vector lesson here. Our next milestone is kinematics. See you there.